Day 15 of 60, and today we weaponize trust. Server-side request forgery is the bug where you don't attack the server directly, you convince the server to attack itself, on your behalf. Here's why that's catastrophic. A web app that fetches a URL for you can be steered toward 169.254.169.254 and hand over AWS credentials for a box you have zero shell access to. By the end of this video you'll find SSRF where most testers miss it, chain it to cloud metadata, and write a finding that actually proves impact. Let's go. First, recon. Stop hunting only for parameters literally named URL equals. SSRF hides in any feature that makes the server reach out. File upload by URL. Webhook callback fields. PDF renderers that fetch remote images. XML parsers vulnerable to external entities. Document preview and avatar import features. Open burp, trigger a file import feature, and watch the logger. If you see an outbound request from the server's IP the instant you submit, that's your signal. The server fetches on your behalf. That trust is the entire vulnerability. Now confirm it, including the blind variety. Blind SSRF returns no response body, so you need an out-of-band canary. Spin up Interact client. It gives you a unique domain. Drop that domain into every suspect field, https://abc123.ost.fun. If you get a DNS or HTTP hit on the Interact console, the server reached out. DNS-only hit means egress is filtered but DNS resolves, still SSRF, still reportable. Tag which sync fired so you're not guessing later. Confirmed it fetches external hosts, now pivot internal. The question becomes, what can this server reach that you can't? Point it at itself. http://127.0.0.1:8080/admin and the IPv6 form http://1/admin. That bracket trick matters. Naive blocklist regex that only matches 127.0.0.1 sales right past, past 2130706433 as a decimal int, past 0177.0.0.1 octal. Then sweep internal ranges. You're using SSRF as a port scanner, open ports return fast or give a connection refused error, filtered ports hang until timeout. That timing delta maps the internal network. Here's the escalation that turns low to critical. The target is cloud-hosted, so aim at the metadata endpoint. AWS IMDS v1, curl http://169.254.169.254/latest/meta-data/im/security-credentials, but you're sending that through the SSRF sink, not your own terminal. That returns the IAM role name. Append it, /IAM/security-credentials/role name and you get back access key ID, secret access key, and a token. Those are live AWS credentials. GCP is the same game with a header, http://metadata.google.internal/compute-metadata/v1 requiring metadata flavor, Google. You just went from a URL field to cloud account access. Why does this keep happening in code? Picture a vulnerable Express app, axios.get, reqquery.url, with no allow list. Developer notices, slaps on a blocklist regex 4127.0.0.1, and you bypass it with, :1, or decimal IP. Blocklists fail because the address space is too large to enumerate. The real fix is an allow list, resolve the hostname, check the resolved IP against approved ranges, and reject everything else, including redirects that bounce back to internal. Know the secure pattern so your report recommends the right thing, not just sanitize input. Now the part that separates juniors from pros, reporting. A weak finding says application fetched an internal resource. That's it. No impact, gets triaged low, ignored. A strong finding splits three things cleanly. 1. The vector, exact parameter, exact request, the import feature on /API/upload. 2. The reachable internal surface, MDS responded, ports 8080 and 6379 open internally. 3. Confirmed impact, extracted live IAM credentials for role web app prod, validated with AWS STS get caller identity. Each step gets a curl command the defender can paste and reproduce. Proof beats adjectives every time. 2. Tradecraft limits, because discipline matters. 1. Those harvested credentials are scoped, don't go spraying them across the account beyond what your rules of engagement allow, prove access, then stop. 2. Blind SSRF with DNS-only egress may not reach metadata at all. Report what you confirmed, not what you assume. DNS exfiltration possible, HTTP egress filtered, is an honest, useful finding. Overclaiming gets your whole report questioned. Day 15 done. The takeaway, SSRF isn't about reading /etc/password, it's about reaching the one unauthenticated endpoint that hands you the keys, then proving it with reproducible curl. Subscribe for day 16.